Hello 20-1 students. So today we're looking at continuing on with lesson 8.2. So we started it last time by looking at solving systems of equations algebraically, but we were just working with kind of like preset systems that were just given the values and we just need to solve. In this lesson, we're going to look at a little bit more in-depth types of questions, so word problems where we have to do a little bit more interpretation of what the solutions mean, as well as, in one case, creating our own system of equations based on the word problem. So let's start out with this first example here where we're looking at Terry makes a good hit and the baseball travels on a path modeled by this function. Ruth is in the outfield directly in line with the path of the ball. She runs toward the ball and jumps to try to catch it. Her jump is modeled by this equation. So we have two kind of quadratic functions there, parabolic, and you can kind of imagine, right? So if we have the ball is flying from one direction, it's going to follow that typical kind of curve. And then if the girl kind of jumps to grab it, it's going to follow the same kind of a curve. And the point where those two graphs intersect is the point where she hits the path of the ball, essentially. And yeah, so that's how we can kind of see these equations being modeled in real life. In both equations, x is the horizontal distance in meters from home plate. So let's say, I don't know, home plate is over here. Our x value is going to be the distance away from it. And h is the height of the ball above the ground. So h is our, our horizontal one. And so wherever this intersection happens is going to be the height where the ball is when Ruth catches it. So we want to solve the system algebraically. Now on the filled in notes, I use substitution for this one. For this one, to mix it up a little bit, just so you can see a different way, you can always check those filled in notes to see how substitution would work for this example. And I will use elimination for this one, because the elimination we use for a question like this is maybe a little bit different than the way I explained it in the last one. With this one, because we have h and h, those are our simplest variables that we would say are the same variable, right? But we need them to be opposite in sign. So what we did in the last lesson was we would have multiplied everything through in, say, the second equation, for example, by -1 and then added the two equations. In this one, I'm going to simplify it even a little bit more and just say h, in this case instead, the same thing mathematically would just be to subtract off this second equation. So let's go ahead and do that. We're going to have h equals -0.1 x squared plus 2x minus h equals -x squared plus 39x minus 378. Okay, so if we combine those, h minus h is 0. -0.1 minus -x is the same as plus, so we end up with 0.9x squared. 0.9x squared. 2x minus 39x gives us -37x. And we don't have a numerical value there, so it's kind of like saying 0 minus -378, which would be plus 378. So now we get this function. We see that the values are pretty complex, so we're not going to try and work that by doing swing method or anything crazy like that. We're just going to jump right into the quadratic. So that is going to be -b, so -37 gives us 37 plus or minus the square root of b squared, so 37 squared, minus 4 times by a, 0.9, times by c, 378, and divide all of that by 2a, so 2 times by 0.9. Now you'll notice on the filled in notes that I have opposite values for all of these, but because they're all exactly opposite, so I had like -0.9, positive 37, and -378, it'll all come out the same when you run it through the quadratic equation. So we end up with, let's see, 37 plus or minus the square root of 8.2. divided by 1.8, and that will give us, if we do those calculations, if we add the root, we end up with 18.96. If we subtract the root, we end up with 22.15. All right, so now we just want to substitute the values in to solve for height. So either one of these x values, neither one of them is negative, so either one of them could work. Technically, because we're looking at the distance from home plate, even a negative x value could technically work here because they could be in the negative direction from home plate. So we want to work through to solve for h to see if either one of these solutions is eliminated. So in the first one, let's just use our nice easy equation here. So negative 0.1 x squared, so 18.96 squared, plus 2 times by x, 18.96, and that's going to give us h, and so we end up with h being equal to 1.96. So that would mean one of the possible solutions is that she is 18.96 for her x value, so 18.96 meters from home plate, and 1.96 meters above the ground when she catches the ball. Second possible solution would be negative 0.1 times by 22.15 squared plus 2 times by 22.15 is equal to our height. And if we run through those calculations, we get a height of negative 4.75. This one does not make sense, right? We can't have the ball be a negative height. That would mean that it was below ground. So this solution we can just kind of eliminate, and we would say that this is our proper solution here. In the second part of the question, we're asked to explain the meaning of the point of intersection. I've kind of already done that, so just make sure in a word problem on a test you would write that out nicely, that Ruth is 18.96 meters from home plate when she jumps to a height of 1.96 meters to catch the ball, and the ball is at 1.96 meters when she catches it. The second part is, what assumptions are you making? Basically, with questions like this, when you think about assumptions, you're essentially just thinking about what real life things might happen that would interfere with this being a solution. So for example, if somebody else caught the ball before she did, maybe she can't actually jump to that height, because technically this is just, we're saying where her path needs to intersect with the height of the ball in order to catch it. So just different real life things like that might have interfered with that solution being what happens in real life. All right, so you can pause the video. We have a question that's pretty much the same as the one we just did. So give it a try, see if you can come up with the proper solution. The solution is on the filled in notes on the website as per usual. So you can check your answers there, and then we will move on to example 2. So in this example, we are not given our equations, but we're given some information and we need to write a system of equations that relates to the problem and then solve it. So we have kind of 2 different steps to work through here. So in the first part, we're told determine 2 integers. So right away, I want to set up my variables. So 2 integers, let's call integer 1 x and integer 2 y. So now I have references for both of these that I can refer to as I move forward through the question. So these integers have the following relationships. 14 more than twice the first integer gives the second integer. With questions like this, it's really important to think about what verbal cues are indicating in terms of mathematical functions. So 14 more than something means you have that value and you're adding 14 to it. So more, just think about that as always being adding to. Twice the first integer, so if we say 2 times, 3 times, twice, however you want to say that, that's multiplication, right? Because twice is another way of saying 2 times. So 2 times the first integer. So we said our first integer is x, so I'm going to start out by putting in my x. We're looking at twice the first integer, so 2 times by that x value, but we have to have 14 more than twice the value of the first integer, so I'm going to add 14 to that. 14 more than twice the first integer gives the second integer, so gives is another way of saying is equal to the second integer, which is y. So now we have one equation. The second integer increased by 1. So again, think about what does that mean mathematically. If we have the second integer, which is y, and we increase it by 1, what are we doing? We're adding 1. Is the square of the first integer. So is, what does that mean mathematically? Well, it means is equal to the square of the first integer. So our first integer squared. So now we have our system of equations, our two equations. Now we just need to go ahead and solve it just the way we normally would. Because we have a linear and a quadratic here, I like to use substitution because we already have y is equal to. So let's take what y is equal to and sub it into our second equation. So 2x plus 14 is subbed in for y, plus 1 equals x squared. So if we simplify this, basically we combine the two numerical terms, 2x plus 15 equals x squared. And then in order to factor for x, we want to have everything on the same side, so we make a nice quadratic. So because we have positive x squared, let's move this stuff over to the other side. So minus 2x minus 15. And we're going to do that to both sides. So this is going to add up to 0 is equal to x squared minus 2x minus 15. Okay, now just factor that out. Two numbers that multiply to negative 15 and add to negative 2 would be x minus 5. So negative 5 times by negative 3 gives us negative, or sorry, no. One of these is going to have to be positive. If we have negative 5, we would need to add 3 to get to negative 2. So negative 5 times positive 3 is negative 15. Negative 5 plus 3 is negative 2. So that means our values for x are positive 5 and negative 3. Now we want to sub them in to solve for our second integer. So the possibilities for our first integer are 5 and negative 3. And if we sub them in for our second one, so we already have y is equal to, so let's use that, 2 times by x, so 2 times by 5, plus 14. So 2 times 5 is 10 plus 14 is 24. So our first solution is x equals 5, y equals 24. So if we want, we can really quickly think here, is this true when we read these relationships? 14 more than twice the first integer. So our first integer is 5. So if we have twice 5, that's 10, and 14 more than that is 24. Gives the second integer. So yes, that's correct. We could also look at the second one. The second integer, so 24, increased by 1, which would give us 25, is the square of the first integer. And yes, 25 is the square of 5. So that system works. So that's one possible solution. Let's see if negative 3 works. So y is equal to 2 times by x, which is negative 3 in this case, plus 14. Y equals 2 times negative 3 is negative 6 plus 14 gives us 8. So our answer would be negative 3 and 8. Let's see, the second integer, let's just try this one. The second integer increased by 1, so if we increase 8 by 1, we get 9, is the square of the first integer. So negative 3 squared is 9. So that works out. I'm not going to check the first one with you guys. So basically, if you guys were doing this on a test, just make sure you have a nice written answer there saying two integers with this stated relationship are 5 and 24 and negative 3 and 8. Okay. So you guys can try a similar type question here. Again, maybe just pause the video, give it a try, and then you can check the solution on the filled in notes on the website. Okay, so for, go through a little focus here. So for example 3, we have a crate drops freely from a plane before a parachute opens to bring the crate gently to the ground. The crate's height in meters above the ground, t seconds after leaving the aircraft, is given by the following two equations. So the first one represents the height of the crate during free fall. The second one represents the height of the crate with the parachute open. And they're asking us how long after the crate leaves the aircraft does the parachute open. So essentially what we're looking for is the place where t is the same for both of these, where we have, well, I guess t and h would be the same, right? For both of those. So what does that mean? Well, that means the intersection point of these two graphs because they have the same x and y values. Okay, so essentially what that means is we're just going to be solving these the way we always do with these systems. So express your answer to the nearest hundredth of a second. So in this case, we're just looking to solve for t because they're looking for how long. So we're looking for the time. So let's go ahead and consider how we could do this. So if you want, you could do elimination again the way we looked at in the first problem. You could just subtract off the second one. I'm going to use substitution this time, especially because we have this nice linear one that's going to be easy to sub in. So I'm going to put in this negative 4t plus 500 is equal to h, so I'm subbing it in for the h here, negative 4.9t squared plus 900. And then I just want to move everything to the same side so I get a nice quadratic that I can factor. So that means I'm going to do plus 4t minus 500. And I'll do the same thing to the other side. So these are going to cancel out to give 0. And then on this side, I'm going to have negative 4.9t squared plus 4t. There's no t value on this side to combine it with, so it's just going to be plus 4t. And now I have plus 900 minus 500, which gives me plus 400. Okay, so there's my equation. Now again, kind of crazy numbers, so let's go with the quadratic. We're going to do t being equal to negative b, so negative 4, plus or minus the square root of 4 squared, which is 16, minus 4 times by a times by c, which is 400, and put in my square root sign there, and then divide by 2a, so 2 times by negative 4.9. So that's going to give us t being equal to negative 4 plus or minus the square root of 7,856 divided by negative 9.8. And so we end up with t is equal to either negative 8.64 or t being equal to 9.45. Now, 9.45. So what we just want to think about here is, because it asked us to express our answer to the nearest hundredth of a second, and all they were asking for was the time. So we have two possibilities for time here. Right away, we know there's no such thing, well, I guess we don't talk about negative time. And so this solution is out. So we want to use our positive value here. And if we had this question in a test, we would nicely write out the parachute opens 9.45 seconds after leaving the aircraft. The second part asks us to solve for the height above the ground where the crate is when the parachute opens. So we're saying at this time, how high was the crate basically. So we're subbing in time into one of our equations. Let's use that easier one, the negative 4t plus 500. So h equals negative 4 times by t, which was 9.45, plus 500. And that's going to give us height being equal to, also here, make sure you do use your extended decimal, even though you rounded it for this answer, so that you get the most accurate value. So we end up with 462.2 meters. And again, for a written question on a test, you would write out nicely, the crate is 462.2 meters above the ground when the parachute opens. Okay, so that's everything for today. So you have a chance to try the same question yourself. Again, check the filled in notes for the solution. And then you have an assignment to work on from the textbook that is word problems similar to this. And then you can go ahead to the chapter review and the chapter practice test in the textbook, because this is the end of this chapter for us. So good luck on the chapter test, and I will see you in our lessons for chapter 9.